Hello everyone, this is Gnaneshwar Sairam, rule number 21951805552, and this is my ADE Techtalk, and my topic is solid state drives. In this, we study about history. We know about history, what is solid state drive, NAND flash memory, SSD elements such as SSD controller, SSD flash, SSD interfaces, SSD storage scheme, SSD architecture, SSD around us, Intel X25, SSD an example, benefits of SSD, SSD versus HSD, and its applications. History. Storage devices are involved as a use of machines in is increasing. Punch cards in 1940s, magnetic tapes or drivers in 1950s. Hard drives. Solid state drives. Solid state drive SSD. SSD is a PC storage device that uses solid state memory to store information. SSD uses non-volatile NAND flash memory which enables it to retain data when the power is removed. NAND flash memory. So what is NAND flash memory? NAND flash memory is a key component of SSD. It is a specific type of EEPROM chip. It is a grid of columns and rows with a cell that has two transistors on each intersection and control gate and floating gate transistor. The principle of operation is based on MOSFETs, and this is the circuit diagram of SSD. Types of NAND flash: single level, multi level, SLC or MLC. SLC versus MLC. The item voltage SLC 3.4 by 1.5, MLC 3.3. The item used in SLC, the chip size is 0.12 UM and in MLC 0.16 UM. Page size or block size 2 KB per 2 KB to 128 KB. In MLC 512 bytes to 32 bytes or 2 KB to 256 KB. And access time is 25 years and MLC is 70 microseconds. The endurance is 100K in SLC and 10K in MLC. Cost per bit is more as compared in MLC it's comparatively less. And write data rate is 8 MB per second and in MLC it is 1.5 MB per second. SSD elements. SSD consists of basically three elements: SSD controller, SSD flash, SSD interface. As you can see on the screen, SSD controller. Flash controller includes the electronics that bridge the flash memory components to the SSD input or output interfaces. The controller is embedded power processor that executes the firmware level software. SSD controller block diagram. SSD controller has a processor, ECC, flash controller, DRAM controller, that's dynamic RAM controller, IO interface, and controller memory, chip configuration. The diagram as you can see on screen. SSD flash. Solid state flash memory is available using NAND technology. NAND flash components come in densities from 1 GB to 64 GB per chip. NAND flash components have structures called page and blocks. There is an error correction code ECC associated with each sector. NAND flash has limited read-write endurance of about 1 million times per block. SSD flash block diagram. It contains data interface, IO controller, control logic, address register, data cache register, and status register, row column decoder, and flash array. As you can see on the screen, SSD interface. Interface is used to connect the SSD with a computer. Also, since SSDs are generally used in conjunction with magnetic disk drives, a common mass storage bus interface is used to in most cases. SSDs are available in a variety of system interfaces based primarily on the performance requirements. Seriality SCSA, fiber channel, USB, and SSD storage scheme. Computers of NAND flash cells are organized into pages and these pages organized into blocks. Read and write operations can be performed on pages, but erase operations can only be performed at the block level. This means when when rewrite a page, the entire block must be erased first. The SSD controller manages this process. As you can see on the screen, the left side is page and right side is blocks. The smallest rewritable unit is a page and a block composite of many pages. The smallest erasable unit is a block and it holds 512 bytes of data. SSD architecture. You can see on the screen it contains host system that in it operating system software, file system is W, input output driver is W. To connect to interface, control firmware, addressing, data buffer cache, error correction code, flash memory component units. SSDs around us. We can see SSDs in many types like multimedia memory cards, thumb disks, embedded systems, mobile media players, solid state drives in systems. Intel X25 SSD, an example, certified of 25 Mbps read speed and 70 Mbps write speed. MLS SSD standard 10 channel memory controller. Each channel is responsible for two memory chips. Intel X25 SSD. It controls IO microcontroller Intel PC 29AS 21AA0 SPI flash cache. Flash storage Intel 29F3 260 CAMCI and NVRAM Samsung 843 K4281 62K UC60 16 MB HD RAM. Serial ATA and serial ATA power. Benefits of SSD: faster startup of solid state drive, faster access, faster applications launch time, more efficient, more energy efficient, more reliable, and more reboot under the extreme conditions, and lighter in weight. SSD versus HDD. You can simply differentiate SSD versus HDD as shown on the screen. Applications of SSD. SSDs are mainly used in those aspects of mission critical applications where the speed of a storage system needed to be fast as possible. Organizations that can benefit that from fast access of the system data, including equity trading companies, telecommunication corporations, and video streaming. SSDs are used as cache at the server side of the enterprises. References from wikipedia.org. Thank you.